All right. So we want to find the zeros of this polynomial. So take a sec, try this on your own, see what you get. All right, so what I do see here is I do see a common ratio between the first two terms and the last two terms. And it might not seem like it, but it is. The common ratio is 1.5. So 2 times 1.5 is 3. 18 times 1.5 is 27. So what I'm going to do here is I'm going to use grouping because I see 4 total terms, 1, 2, 3, 4, and I see a common ratio between the first two and the last two. So I am going to use grouping as a strategy. So with grouping, oh my goodness, with grouping, I'm going to take the greatest common factor out of these, which is x squared. So I'm going to take x squared out, and I'll be left with x, it should be 2x plus 3. Let's check that. So x squared times 2x is 2x cubed. Yes. And then x squared times 3 is 3x squared. Yes. And then minus, and again, I can cheat, and I know that 2x plus 3 has to be in here if this is going to work. You can also say, just think to yourself, what can I pull out of these two? And that would be -9. If you pull out -9 times what is 18x? That would be 2x. -9 times 2x is -18x, and -9 times +3 is going to give you -27. So what you should be able to see that this expression here, -9 times 2x plus 3, is the same as -18x minus 27. And x squared times 2x plus 3 is the same as 2x cubed plus 3x squared. So again, we're not changing anything, we're just rewriting. So now with grouping, again, 2x plus 3 is like our common factor. So I'll pull out 2x plus 3. And what's left is the x squared minus 9. A lot of people get confused if there's no number here. If there's nothing here, this would be x squared minus 1. But because there is a 9, it's going to be x squared minus 9. So from here, I can set this factor equal to 0 and solve. This I can factor further. Hopefully you can see the pattern here. I can factor this as x plus 3, x minus 3. This is known as a difference of squares, a very common pattern you'll see in a textbook. How common it is in the wild is probably not, but in a textbook, gotta love these examples. A difference of squares, so beautiful. Factor it as x plus 3, x minus 3. So now at this point, right, again, think, why did I factor? Why did I do this? What am I doing here? I'm trying to find the answers, the solutions. What numbers can I plug in to make this whole thing equal to 0? When I read it like this, it's easier to see. I can plug in 3. Actually, I can plug in 3 here. So I should have written it to the right. So I can plug in 3. I can plug in -3. So these are 2 solutions. And then if I set this equal to 0, 2x plus 3 equals 0, 2x equals -3, x equals -3 over 2, which is -1.5. So my 3 answers are 3, -3, and -1.5. So let's go ahead and graph those. So 3, -3, and -1.5. Just as a rough sketch, just a couple things you need to know. End behavior. So it's positive cubic. So it's up on the right, probably not that vertical, down on the left. Y-intercept is -27. So it's way out here. Please forgive me. And it's something like that. Up on the right, down on the left, y-intercept of -27. 3 zeros. Fun stuff. All right, let's take a look at this last one here. All right. So this one here, we have a couple things we can do. What I'm going to do is I'm actually not going to factor this. I'm going to leave this till the end because we can find the zeros without factoring that. Here, this we can factor. The A equals 1. The leading coefficient is 1. So this makes this easier to factor. I need 2 numbers that multiply to AC. For us, A is 1, C is 6, that means AC is 6. And I just wrote that out just to make sure everyone is understanding what that means. AC means A times C, the leading coefficient, times the constant. Here that is 6. Not 7, 6. And then B is -5. So I need two numbers that multiply to +6 and add to -5. So take a sec, get those numbers in your head. I'm getting -3 and -2. So it looks like I can factor this as x minus 3 times x minus 2. You could always check that. -3 times -2 is +6. Nice. X times x is x squared. And then we get -3x, -2x. That gives us the -5x. So I do like this. So notice I just rewrote x squared minus 1. So I just rewrote this whole thing as x squared minus 1. So I kept it, but then I rewrote the second part as x minus 3 times x minus 2. Now, instead of rewriting this, I'm just going to show you, you can find all of your zeros from here. So what numbers can you plug in to make this whole equation equal 0? There are going to be 4 solutions. Why are there 4 solutions? The highest exponent, it might look like it's 2, but remember these get multiplied. And when you do x squared times x squared, that gives you, it's going to give you x to the 4th. So you're looking for 4 answers. So your first answer is 3, because you can plug in 3 here. It's going to make the whole thing equal 0. Your second answer is 2, because you can plug in 2 here. And we need 2 more answers, and we're going to get them here. So if we set this equal to 0, you're going to get x squared equals 1. So x equals plus or minus 1. Right? The square root of 1 is 1 or -1. 1 times 1 is 1. -1 times -1 is 1. So I'm going to get 1, -1, 3, and 2. So there should be all of my answers. 1, -1, 3, 2. This is a positive quartic function. Even degree is what matters. So with an even degree, the end behavior is either going to be up, up, or down, down. This is going to be up, up, because the coefficient is positive. There's no negative number in front of this. So it's going to be up, up. My y-intercept is going to be -6. How do I know that? I got my 6 times my -1. That's going to give me a -6 at the end. So I got a y-intercept of -6. No multiplicity, so it's going to give me a pretty standard shape. And again, this is not going to be the exact shape, but it's the right idea. It's the right idea. It's ending up on the right, up on the left. Y-intercept of -6. It's going to be negative in this whole interval, positive in this whole interval, and negative in this interval. So that's kind of what's going on here with this graph. All right. So